In this section, we're graphing parabolas. A quadratic function is a parabola, and a quadratic function, of course, is a polynomial whose highest power is 2. So when you start graphing things for this particular class, a parabola is going to have this shape, or it's going to open downwards, one of the two. In future classes, it can also open left or right. A parabola has two basic features. Okay, the first feature we call the vertex. This is an example of a vertex for our generic polynomial. The vertex is the turning point of the parabola. That's where it stops increasing and starts decreasing, or vice versa. The second part of the parabola, that's a foundation piece, is something called the axis of symmetry. The axis of symmetry is a dotted line down the center that's kind of like the backbone. It is the axis of symmetry, which means if there's a point on the right that's, say, 2 places away from the axis, then there's also a point on the left that's 2 places away. So those are your major components of a vertex. So you have your rules here, your notes, so to speak, and so we're going to use these notes to graph one. Okay, so I'm asking you to graph and find the vertex, axis of symmetry, and max or min for this function. I'm also going to throw in the bottom the concepts of domain and range. Okay, for this particular form, what we have is what we call ABC form. It can also be called quadratic form. It's your same ABC form that you used when you did the quadratic formula earlier this semester. So your A is located here, your B is located here, and your C is located here. The first thing I'm asking you to do is to find the vertex, and you have a little formula for the vertex. The vertex is actually where the x component equals negative b over 2a. And you can find those notes on your previous slide. So in this particular problem, b is 4. So you're going to say that negative 4 over 2 times a. So that's negative 4 over 4, which is a negative 1. Now a vertex is a point, it's not just an x value, so it's actually going to be the point negative 1 something. I don't know what that something is. The way that we find our y value is we plug in the x value. So we're going to plug into the function x equals negative 1, and that'll give us our y value. So f of negative 1 equals 2 times negative 1 squared plus 4 times negative 1 minus 3. Okay, so that means that my vertex, going back to the top, my vertex is 1, negative 5. I'm sorry, that would be a negative 1. Don't leave off the negative. So it's a negative 1, negative 5. So going to my graph, I'm going to start at the origin and go over to negative 1 and then down to negative 5. So there I am, and that would be my vertex. Step 2 says find the axis of symmetry, and it's very easy to find. Your axis of symmetry, if you look back at your notes, says x equals negative b over 2a. You've seen that before. That's the first number of the vertex. Now I do want you to keep your axis of symmetry as an x equals equation for this class because it's going to be a vertical line. X equals negative 1. The axis of symmetry always goes through the vertex. So what I'm going to do is draw a dotted line. That's going to be the backbone, the center of my parabola. Moving on along, the next thing you see is A, and you would be tempted to think that A is your axis of symmetry, but it's not your axis of symmetry. A is the number in front Now that's a little misleading. It's the number in front when the function is in standard form. When it's in standard form, it's the number in front. Now, let me erase these. So right now we are in descending order in standard form, so that tells me that my A value is 2. On your previous page in the notes, it says if A is positive, your graph opens upwards. So I know this particular graph is going to open upwards. At this point though, I don't know if it's thin parabola or a fat parabola. I don't know which one it is. I don't know the thickness of it. So we're going to go to step 5 and use step 5 to determine the thickness of this parabola. It tells you to pick additional points, and it says pick something close to the vertex. Now, you can pick whatever number you want. I like to pick 0 because it's easy to plug in, but you can pick whatever number you want. Okay, I'm going to pick 0. Okay, by personal preference, again, I picked 0. You could pick whatever number you wanted. If you plug 0 into this function, you get 0 plus 0 minus 3. So you're going to get the point 0, negative 3. Now, I can use that axis of symmetry to my advantage. See how that orange point is one place away from the blue dotted line? It's one place on the right. Well, if you go one place on the left, you will have a second point. That blue dotted line has to divide the parabola in half. That means if there's a point one place on the right, there's also a point one place on the left. Now, once you get there, all you have to do is draw your graph. It goes down and then turns back around, and that's how it looks. Now, problem number 6, or step number 6, says, is this a max or a min? Let me talk to you about a max or a min for just a second. The vertex is always either the highest point or the lowest point, and that means it's either the maximum point or the minimum point. So if I look at this red dot on here, I'll see that's the lowest point on my whole graph. So since that's the lowest point on my whole graph, that means there's a minimum. And the minimum occurs at -1, -5. It will always be the vertex. You can't have both a max and a min in the same problem, so it will always be one or the other. Okay, the last thing I asked you, and this really affects my online classes more than my other classes, for domain, that's the set of all x values, and the range, that's the set of all y values. So the last thing that they ask you to do in the MyMathLab homework is they'll ask you to tell the domain and range of this graph. Okay? Well, domain is a set of all x values. What I notice about this graph, of course it's a little rough sketched, but what I notice about it is it's going up, 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 but as it's going up, it's also going out. So that means it's going out in both directions and also up. That means all x's are covered. Now, another way that you could look at the domain is go back to the beginning function. When you look at the beginning function, you'll notice it doesn't have a denominator, it doesn't have an even radical. So, using previously taught concepts, the domain of this function would be all real numbers. The range is the set of all y values. So, if I look at this particular red part right here, this red point, that's the lowest that the y's go. So they start where that point is and they go upwards. So the range of this one would be -5 because that's your y value at the red point, and then it goes up forever. So your range would look like that.